Welcome back. So we're looking at question 4. Just in question 4. So now we're having to go at question 5. Question 5. That'll pretty much bring us to the end of this particular tutorial. So that's always good. Alright, so in this case here, we're treating it like these IVP type questions. So we're just integrating, aren't we? Really, that's what it's about. So integrating. So it should be fairly straightforward for us. Question 5. We have a differential equation. That is, so we integrate dy dx. We also integrate x squared dx. This has the effect of undo. So we're left with y is equal to the integral of x squared dx, which is up and under x3 on 3 plus c. Now we're told that as an IVP we have an xy pair, xy coordinate pair, such that when x is 1, y is 1. So to get the final c value out, we just use those values. So 1 is equal to 1 cubed over 3 plus c. So that's just 1/3. So therefore c is equal to 1 minusing 1/3 from both sides, minus 1/3. Same family, we can go through all of that, but it's clear that that's 2/3. Don't normally say that, do I? So while that's the general form, or the general solution, the particular solution is y equals x cubed 3 plus 2/3. That represents the equation that is the solution for this expressed form, okay, of dy dx. So just getting used to these d's is a simple, trivial thing, but it's more advanced in Maths 1. So it's not a bad introduction. Okay, so we'll integrate both sides. So y will become the integral of 1 minus x dx. That'll be our function. So y will become up and under. We will get x minus x squared on 2, that's up and under, plus c. Now we're told, so that's our general solution, that y will satisfy the equation dy dx equals 1 minus x. Now we're told that the x and y are 0. So if we put in 0 equals 0 minus 0 squared over 2 plus c, therefore c is equal to 0. So the final particular solution is just the part without c. So we get x minus x squared on 2, or half x squared as I've been writing them previously, and that's the particular solution for that particular problem with those initial conditions, IVP. They represent your initial value. Alright, so for part C, y will be the integral of cos 2x dx, and the points of interest are 5, 4, and 1. So we can simply do those. Now this requires a U substitution, doesn't it? So we let U equal 2x, du dx is then going to be equal to 2, and after some manipulation, 1/2 du equal to dx. So we'll end up with dx being swapped out for du, 1/2 integral of trivial cos u. Differential sign is cos, so the integral of cos is sine. So we get 1/2 sine u, and sine u was 2x plus c. So that's our general solution. Now our particular solution will have put into it y and x and y. So we need to solve for c. We're getting 1/2. So this is where your exact values trig will need to kick in. And x was pi on 4 plus c. So it's taken us a while for us to revisit exact values trig, but they're going to come up in spades. So pi on 2. So what does sine pi on 2 look like? Pi is here, pi on 2 is here, so it's a diminished triangle there, which is 1. So the y value is 1. Okay, so it's come right up to here. X is 0, so we get 1. Now that's exact values trig, 1/2, 1 plus c. So therefore 1, subtract the 1/2 on both sides. Therefore c is equal to 1 minus 1/2, which is 1/2. So our particular solution for this one is 1/2 sine 2x plus 1/2. So that's our particular solution for the initial value problem. Alright, so the final one was D, so that was a good sample of what you'll be expected to do. Your exact values trig. I did it in my head, did it without a calculator, so that'll be forthcoming. Alright, so D is the integral y of both sides, so dy dx will yield y. It'll be the integral of 1/5 minus x dx, and this is quite straightforward. Is the derivative of the denominator on the numerator? No, but it could be if we had a minus 1 over a minus 1, because that minus would then go up there, and we would have minus the integral of minus 1 over 5 minus x. Now we can ask that question. We could use a u sub. I'll leave you to do that. Is the derivative of the denominator on the numerator now? The answer is yes. So therefore, y, see how it makes you think about the minus minus idea? Minus ln the denominator plus c. So that's our general solution. Okay, and we're being asked to find our initial value problems of x is 4 and y is minus 1. So we simply substitute those back in. and we'll end up with minus 1 is equal to minus the ln of 5 minus 4 plus c, which is minus 1 equals to minus the ln of 1 plus c. Now the ln of 1 is 0. So this is 0. So that term is out. So therefore C is equal to -1. See how the maths goes together? So our particular solution becomes y equals the minus ln with these initial value problems, 5 minus x minus 1, and that is our particular solution. So our general solution is up here, and our particular solution is here. Okay, so very straightforward, I think, but anyway, good practice for integration and the use of integration. All right, that's it for me for the tutor this week, so I will see you next time.